We're going to look today at local LLM inference through Cursor on a new M5 Max MacBook Pro. So we've got quite a lot of memory here. We've got 128 gigs of unified memory. So the question is here, what kind of models can we run locally and what's the quality of the output, as well as getting to use them in agent mode in Cursor itself. So we're going to be using LM Studio and Cursor, obviously, and then to bridge the gap between those two things, we're going to be using a system called ngrok, which you can apply. You can sign up for a free account online. It's been quite easy to do, so I've already done it, but I'm going to basically walk you through how that's done, and then we'll look at some performance from it. So what you want to do in Cursor is up on the top right. This is the current version of as of the making of this video. Open Cursor settings, and then in models, firstly, when you view all models, we'll come to the bottom here and add custom model. Then you want to add the model that you're using locally in LM Studio, just the name of it. Then down here in Open API settings, in the API keys, we're basically going to override the URL that it thinks is OpenAI. And what we're using in here is the ngrok domain that it gives us, which we'll walk through how to do that. Now, in ngrok itself, when you sign up for a free account, the instructions are very easy to follow. It will give you the API key, and it will give you a URL. And basically, when you go onto your terminal, once ngrok is installed on your local machine, you use ngrok, then HTTP, and the URL is the one that it gives you, and the port is the port from LM Studio. So if we go onto the server here, we can see it's reachable at the local host, essentially, and then port 1234. So when we go into here, we put that one live, and it's now communicating with our LM Studio through the public internet. If we go back onto Cursor, we've put that we're doing our own API key, and this URL is now the URL from the ngrok from the terminal. So the API key here, importantly, is not the one from ngrok. It's important to get this right because this had me in circles a couple of times. So the API key here is the API key from LM Studio. So in server settings, require authentication, manage tokens, you need to create a token here, and that is the token that goes into Cursor, into this bit here. So once you've got that set up, it is quite simple, and we're going to load the model here, and we're going to load the Nematron 3 Super, which is one of the bigger models. It's 120 billion parameters. It's about as big as you can comfortably fit onto this MacBook. So we'll just wait for this to load in, and then what we're going to do is compare the output of this to the output of Claude Opus 4.6 and see, for that advantage of the fact that you're able to run this locally, how much are you losing in terms of the performance of the model, given that Opus 4.6, firstly, is not open source, and secondly, could never run on this kind of hardware. So just a direct comparison there. What we're going to ask it to build, we're going to ask it to build in one go a Python script that can open an OpenGL viewing window and rotate around an STL mesh file. So essentially what we're talking about is a 3D model viewer, opening a 3D mesh and seeing if it can do that in one go. So here's the prompt we're going to use. So we want a Python script which will open an STL mesh file. It should be cross-platform because we're on macOS, and it should let the user rotate around the model, zoom in and zoom out just with mouse controls, and it should include a file picker for the user to pick the exact file. So we've got an STL mesh. It's just one that I downloaded from free3d.com, and we'll get Opus 4.6 to do its attempt first. We'll also set a timer here. So here we go. So that's it done. That was about 30 seconds. it wants us to install Pi Vista, so we do have a virtual environment ready to use. So we'll just get into that environment. I believe this is Python 3.14. So let's give it a go and see Claude Opus 4.6's output. There we go, there's our file picker. Pick our dragon. Oh wow. There we go. That's your one shot and done. We've got zoom controls. I've got pan with the middle mouse. I've got zoom with the right mouse button, and a great orbit. We can see the triangles on there, and it's introduced some lighting. So we've got some shading, and we can see what's going on. So I'd say that's a perfect one shot from Claude, and no complaints there whatsoever. That's brilliant, that one. Let's now copy our prompt over, change the file to the local LLM so that it's filling this empty folder, this empty file. And now we're going to switch this to the NVIDIA model that we've got locally. So we'll see the request coming through on LM Studio, and need to get ready to start the timer again. And here we go. Generating here, so yeah, about 36 tokens per second. I have quite a lot open. I've got obviously OBS recording. I've got some YouTube chat tabs in the background, but nothing else is too demanding. So I suppose we're near full potential. I've got it loaded in with the highest context length possible, and we'll just see where we're going. So obviously the prediction is it will take a lot longer to do anything, and really it's about, does the quality of the output match? Because in my personal circumstances, I don't really mind if things take a lot longer, but if they take a lot longer and then the output is not comparable, then it's a non-starter. So straight away, the local model's gone for Pi Vista as well. And there we go, that was 1 minute 5, so about double the length, and we'll see if this works from the get-go. File attempt, file picker there. So this has opened it in a matplotlib axes there. It's plotted the axes, which I'm not too sure about, but I suppose, to be fair, it has done what we asked. We can open the file, we can zoom around it, and the controls are exactly the same. So that took about a minute, and I guess you could make the argument that if you were wanting to examine an STL file, you'd want to know the dimensions. So pretty happy with that performance, and that's all run locally, and of course all the tokens are for free. So the local model definitely didn't struggle as much there as I thought it was going to do. I've had them, obviously it's gone through the Pi Vista library. I've had them before when they've just done it in Python and OpenGL, where writing the OpenGL code, I think they do it through Pygame, gets a lot more complicated and the local one struggles. But they both went basically for the same overall strategy here. I'm not quite sure about the matplotlib approach. Let's maybe try it again, because of course this is through matplotlib. It's really plotting the mesh rather than showing it in a window as if you could use it in a game. Let's retry these and reconfigure our prompt. So open a cross-platform viewing window. with OpenGL and let the user rotate around and zoom. So I kind of want to get away from the libraries doing all the heavy lifting, because it really crunches down the code lines, and it's almost, the more libraries are doing the work, the more trivial the task becomes. So let's try and see it write some more stuff from scratch, and we'll go with Opus here. So I won't be timing them now. Let's just see how they go. So we've still got the TK file dialog here, and now we've got some proper OpenGL code. Like, this needs to be done properly, and we've got our rotation and translation variables here, and the actual while loop. So we've got our requirements given to us as well, and let's see how we get on with that. So it's definitely a lot more laggy, and there's some artifacts here. Also, the orbit controls are not as good as they were in the original attempt, but it has done it, and the lag may be caused by the fact that the large language model is loaded into the memory for use on the local model. So that's certainly not a bad attempt. It's still technically a one-shot and done. Opus 4.6 has managed that no problem. So let's move over and check the local LLM's performance. Exact same prompt, and here we go. So about the same kind of performance here, 35, 36 tokens per second on average. The MacBook's really whirring up now. I can hear the fan kicked in. It's still very quiet for the hardware that's running in there, but you can hear the fan is switched on. There we go. So it took a bit longer there, nearly 3 minutes, I think. So I've got our SCL file, Windows, display, a lot more code here. So the same thing, given us our dependencies. And let's see how that one gets on. We've got a problem here. What have we got? Right. So that definitely hasn't one-shot it. I did ask for it to be cross-platform, so let's see what it thinks of this error. Let's see if it can navigate its way through that. So that's a bit... okay, so it's trying to run the command now, but it's not in the virtual environment, so I'm just going to stop it from doing that. So it seems to have tried this one-line fix, and we'll see what difference that makes. I don't know enough about that particular glut issue to know what it's trying to do there, but let's give it a go. Nope, straight away, same thing. In fact, I'm just going to avoid... I want to avoid the context being the issue, the reason why it fails. So I'm going to just reset the context every time, which I found is a general better performance. So now it's put that line in, I'm still telling it it's quit with that same error. So at least it knows that isn't the solution, because that line's already in there. I'm wondering if I need to steer this a little bit, because I think it would do a lot better going through Pygame. But we'll see if it can solve this issue. So just for reference on the hardware, so we can see the tokens going up here. Right, 35, call it 35.5 per second on average. I did try this on I have a Windows workstation at the office that has 64 gigs of RAM, and it's a 48 core Xeon, a twin Xeon processor. And on the much smaller Quen model, that was getting about 4 tokens per second. So the MacBook Pro here is, it's seriously performing well. That unified memory and the GPU that they have, the Apple Silicon just does an incredible job on these, really. Okay, so it's tried to solve it again with some more variables, and it looks like it's added a bit more logging for the error handling. Obviously, okay, we don't need it to output the entire script there. Each query is taking quite a long time. Let's see what we've got here. No, straight away, that's totally not worked at all. It's still the same error. So what I'm going to do, I shouldn't really be doing this, but I'm just going to steer it a little bit. Let's help it along a little bit here. I mean, this is one of those things where your experience is required to help the smaller models, and a non-technical person trying to do any real work with these, it would be so easy to trip up. And I mean, look at the code here. If you're just a regular person that's tried to write a script to do all this, and it's written all this, and it's falling over itself and going around in circles, you've just got absolutely no chance of steering it or debugging this yourself. But when the models are good enough, like Opus was, where it just does it in one go anyway, if that is all the features that you want, it's done. Well, a developer's role is over then. If you're getting to a point where you start to use it for other things and you want to add features, then eventually you'll run into the same argument. You'll run into the same problem as the code base grows, of course. But the day will probably arrive when that isn't the case, and this kind of architectural steering from someone who has some experience will not be necessary. Well, so it read the other file, which I didn't ask it to do. So that's a bit not sure about that, because that's obviously had the other model inform its approach. It also hasn't actually injected the code into the script. It's just, there's no point waiting for that, because it's just given us this, and we might as well just cut and paste it ourselves. There's our mesh file, and there we go. So it's not a great conclusion, really, because it took it from the other folder, because it was in the other file, because it was in the local directory. So can we really say that it's done it? I don't think so. So I suppose that's a pretty good summary of it all, to be honest. When you let it use the libraries and they're doing all the heavy lifting, I mean, those original scripts were only a few lines long, but it did it in matplotlib, and it took some liberties. But when you've forced it to do it a slightly harder way, it really got itself into some issues with the Mac OS problems. At least they seem like Mac OS problems. I don't really know what they are, but certainly not good enough to replace. I mean, that is just the code. Quite annoying there that it went to read that attempt. In fact, let me move that out of the. I'm going to move that out of the directory and make it do it again. Well, so that's a bit of a different approach here then. So it's firstly recommending a fix rather than changing the code. So this could be quite interesting. We'll see how this does. So let's see what it's asking us to do. Okay, now we've got to try its force re. Here we go. Let's see how this one goes. No, straight away back to that same old error. So this has taken some time. I mean, we've been at this for quite a while now, and as you can see, it's not really a good enough solution to just replace it as a workflow. Could you have an okay time writing a single function with it? Yeah, I certainly would have thought so. The script is getting quite long. Um, it's obviously you're a long, long way behind the performance that we were able to get out of Opus 4.6. The advantage is that it's free, but of course, well, the tokens are free. Of course, it's a very high upfront cost to buy the hardware. And is it good enough to replace your coding workflow? Well, definitely not really. It's maybe you could ask it architectural questions. Maybe you could get it to refactor small functions, something like that. And in the future, I personally I predict quite a major rug pull on the. It's trying to run commands here, so let's just stop it doing that. Yeah, I personally predict a pretty major rug pull in the token pricing. I think that it's all quite heavily subsidized at the minute, so having some kind of local option is really attractive to me, and is part of the reason why I've tried to do this experiment. But as you can see, this is a 120 billion parameter model, and uh, you can make the argument that it's giving you a template that would be faster if you were researching this and figuring it out from scratch. I'm sure an experienced OpenGL programmer, well, firstly they probably won't be doing it in Python, but if this was your method of doing it and you already know this stuff, maybe it is still quicker that it gives you a starting template. Goodness me, it keeps creating these new scripts to try and find problems, try and solve the problems. Right, I guess we'll try this script. No, NS exception. No, it's really struggling with this. I guess this is the problem, right? You use these tools to make things faster and avoid writing all this by hand, but if they're not good enough and you're just going round in circles and it's going round in circles, then you're worse off, really, aren't you? And maybe a person who can't write any code would persevere here and keep going, but if you do know what you're doing, then it must be faster just to do these things yourself. Also, some of the external models in Cursor would have run an internet search and searched the error and probably found forum solutions for it, which this obviously isn't doing. I'd say that's probably time to call it a day. Yeah, overall conclusions aren't great here then. So we've got, um, on those initial prompts, it was about double the amount of time taken to do the prompts. And when all the libraries and wrappers were doing the heavy lifting, it was able to do it. But when you've asked it to write it a little bit more from scratch, it's just totally fallen over again and again. It's written these other scripts. It's still not able to solve it. And I can tell what's happened here. It's got these mouse down variables that it hasn't initialized. Let's just give these a go. Just going to try that. Oh, we've got something. A very slow something, but it's trying to do something. What do we have there? Center mesh, max dimension. That, I believe, is a very zoomed in mesh. So mouse button, mouse motion. It's not going to want that initialized there then, is it? Right mouse down. Okay, so that seems to say, there we go. Wow, it's done it. I mean, this is unusably slow. I mean, this isn't the OBS capture. This is just this is just what it's doing. Let me just unload the model and switch the LM Studio server off, because that will offload all the RAM and possibly the GPU. And let's see what we're doing here. So yeah, so it wasn't caused by the LLM being loaded anyway. So I guess we can technically say it got there. I mean, what an absolute mess around that was, and it was only because I knew what it was doing here. It was changing these values that it hadn't initialized, so putting that in solved it. And I suppose that's a nicer place to finish, that it did get there in the end. But wow, what performance, backwards and forwards for a long time, and not a particularly usable solution, although it has done what we asked. We do have an OpenGL instance. We can rotate the model. It has loaded it in. We can zoom. So it has technically done what we asked. So like I've said, certainly not something that you're going to be replacing your workflow with, but it's nice to know that it could get there in the end. And look, maybe you could throw the script at it again and tell it that it's really slow, and maybe it could optimize its way there. A long way off the Opus performance of a one-shot, but at least we got there in the end. So that's a nice place to end things. Thanks very much if you've made it this far. I'm not sure I would on someone else's video, but if you had made it this far, then thank you very much for watching. I hope it was somewhat interesting. The nice thing to know is that you can set cursor up with a local model. So if you have more hardware than me, there are much larger models on LM Studio that you could have better luck with. And that solution through ngrok is quite neat, and it's free, and it works straight away. It doesn't take much setting up, so it's nice to at least know this is possible. And if things really do get rug pulled on price on the LLM tokens through Anthropic or OpenAI, it's nice to know that there's a solution where you can keep working locally. But I certainly won't be swapping over on a day-to-day basis. Thank you very much for watching, and let me know in the comments if you've got any questions or any feedback. If you'd like to see more of this kind of thing and testing the hardware out and looking at programming the software side of things, then we can certainly do that. If you want more content on the hardware side of things, I have plenty to do there as well. So thank you, and hopefully see you next time.